Example 3 says to find the exact value of cosine of 15 degrees. But they help us out here because they tell us to use the fact that cosine of 15 degrees is equal to cosine of 45 degrees minus 30 degrees. And follow the difference formula for cosines. Alright, so now we're kind of doing it the opposite. They said, hey, what is cosine of 15 degrees equal to? We say it's not on our unit circle. How are we going to find the exact value? Because remember, if it just said find the value, we could approximate it. Or if it said round it to 3 decimal places, we could do it. But it says find the exact value, which we all know that means not to use our calculators. But they gave us a clue. It said to use the fact that 15 degrees is equivalent to 45 degrees minus 30 degrees. And so now I have cosine of alpha minus beta. And that's one of our formulas that we just learned. So we know our alpha is going to be 45 degrees and our beta is going to be 30 degrees. Alright, so when I extend this, my formula is cosine of alpha, which is 45 degrees, cosine of beta, which is 30 degrees. The formula's got a plus in it, because remember, cosines changes the sign in the middle. And then we got sine of alpha, which is 45 degrees, sine of beta, which is the 30 degrees. Now, how is this going to help us? Do we know anything about 45 degrees and 30 degrees? We do. They're on our unit circle, aren't they? So let's go through and let's talk about them for a minute. So I'm going to do a little thought bubble over here. What do we know about 45 degrees? Well, it has the ordered pair, square root of 2 over 2, square root of 2 over 2. And what about 30 degrees? Well, 30 degrees has the ordered pair, square root of 3 over 2 and 1/2. And so we're going to use that to help us here. Remember, cosine is your x value on your unit circle. Sine is your y value on your unit circle. So when we do that, then cosine of 45 degrees is the x of the 45 degrees. Cosine of 30 degrees is the x of our 30 degrees. Sine of 45 degrees is going to be the y of my 45 degrees. And sine of 30 degrees is the y of my 30 degrees. Now we know with PEMDAS we're supposed to multiply before we add. So we're going to multiply with fractions. So remember, to multiply with fractions, you multiply straight across. So when I go straight across, in the first one there, square root of 3 times the square root of, square root of 2 times the square root of 3 is the square root of 6 over 2 times 2 is 4 plus, multiply straight across over here, square root of 2 times 1 over 2 times 2. And then we can add those together. Now, remember, adding fractions, you need a common denominator, which we have here. But I can't actually add those radicals, because the only way we can add radicals is if they have the exact same radicand, which is the number underneath it. So I'm going to add my numerators over my common denominator. And since I can't add them, there's no numbers in front of them to help reduce. That's as far as we can go. So there's our exact value of cosine of 15 degrees.